Hi guys, we start the unit 1 of the subject software development methodologies and modeling. In the first unit it's about requirements engineering. We have 3 subtopics. The first one is requirements gathering techniques. The second one, analysis and synthesis of information. And the third one is specification and validation of requirements. In the requirements gathering techniques, we are studying some important techniques like interviews, surveys, observation, and checklist. We start with some definitions, and then we are viewing some processes about these techniques and how to implement it. One of the first activities on analysis on and of an analysis is to determine the business requirements for a new system. Requirements analysis is critical to the achievement of development project. Requirements should be measurable, actionable, and testable, and also should be related to the user's expectations. Requirements without any ambiguity fulfill the user's requirement, make projects successful, while gathering requirements focused on what should be required rather than how it is required. It is estimated that 89% defects are found in requirements during software development. There are some techniques that are used to gather requirements. Every technique is not used to or for every project. In these techniques, some are useful and some aren't, but it depends on the project description. The first thing that we need to understand is what are requirements. A requirement is simply a statement of what the system must do or what feature it must have. During analysis, requirements are written from the perspective of the business person, and they focus on the what of the system because they focus on the needs of the business user. They are usually called business requirements and sometimes user requirements. Later in design, business requirements evolve to become more technical, and they describe how the system will be implemented. Requirements in design are written from the developer's perspective, and they are usually called system requirements. A requirement is a statement of what the system must do, and requirements will change over time as the project moves from inspection to elaboration to construction. Requirements involve from detailed statement of the business capabilities that a system should have to detailed statement of the technical way the capabilities will be implemented in the new system. Good requirements specification is to be complete, verifiable, unambiguous, modifiable, traceable, and usable during operations and maintenance. This requirement specification produce good projects. There are some requirement types. Every project has some kind of requirements like functional requirement, non-functional requirements, domain requirements, and embedded requirements. During requirement solicitation, there may be many issues that have to face different techniques, and which one is best for which type of project we'll discuss, or we look for that later. But what are functional requirements? Functional requirement relates directly to a process a system has to perform or inform it needs to contain. For example, requirements stating that a system must have the ability to search for available inventory or to report actual and budget expenses are functional requirements. Functional requirements flow directly into the creation of functional, structural, and behavioral models that represent the functionality of the involved system. Functional requirements relate to a product functionality, its capabilities, usability, features, and operation as they relate to the intended purpose of the product. Often, functional requirements are clearly referenced as such in functional requirements documentation, while a statement of work outlines the high-level goals and requirements of the desired product, and functional requirement documentation provides a more in-depth elaboration of these requirements, which are gathered as soon as project kickoff and up until a project begins production. Then requirements are not limited to the window of time before production. Change order documentation, warranty documentation, etc. are useful forms of ongoing requirements documentation that occurs through a project. For as long as you work with a client, the documentation is ever growing up and ever evolving. Depending on the size and scope of a project, you might decide on a milestone between the statement of work and functional requirements documentation. In this case, some teams create business requirements documentation to provide a formal midway sign-off for all parties. This presents the opportunity for the project manager to confirm the team is heading in the right direction before getting too far down the road with deliverables. And what are non-functional requirements? Non-functional requirements refer to behavioral properties that the system must have, such as performance and usability. The ability to access the system using a web browser is considered a non-functional requirement. Non-functional requirements can influence the rest of analysis, but often do so only indirectly. Non-functional requirements are used primarily in design when decisions are made about the database, the user interface, the hardware and software, and the system's underlying physical architecture. Non-functional requirements describe a variety of features regarding the system: operational, performance, security, cultural, and political. Operational requirements address issues related to the physical and technical requirements in which the system will operate. Performance requirements address issues related to the speed, capacity, and reliability of the system. Security requirements deal with issues with regard to who has access to the system and under what specific circumstances. Cultural and political requirements deal with issues related to the cultural, political factors and legal requirements that affect the system. These features do not describe business process or information, but they are very important in understanding that the final system should be like. Non-functional requirements primarily affect decisions that will be made during the design of a system. We will check of this kind of requirements later here. Non-functional requirements encompass anything not related to a product functionality. Its performance, stability, security, and technical specifications, to name just a few types of non-functional requirements in the digital industry. When considering ISO 9000 compliance, quality dimensions are further decomposed into those that the user can see, for example external, and those that the user cannot see, or the internal. The external non-functional dimensions include efficiency, reliability, and usability, whereas the internal non-functional dimensions include maintainability, portability, reusability, and testability. But what is a requirement definition? The requirement definition report, usually just called the requirement definition, is a straightforward text report that simply lists the functional and non-functional requirements in an outline format. In the sample requirements definition for an appointment system for a typical doctor office, notice it contains both functional and non-functional requirements. We look this in the image in the slide. The functional requirements include managing appointments, producing a schedule, and recording the availability of the individual doctors. The non-functional requirements include items such as the expected amount of time that it takes to store a new appointment, the need to support wireless printing, and which types of employees have access to the different parts of the system. The requirements are numbered in a legal or outlined format so that each requirement is clearly identified. The requirements are first grouped into functional and non-functional requirements, with each of those headings. They are further grouped by the type of non-functional requirement or by function. Sometimes business requirements are prioritized on the requirements definition. They can be ranked as having high, medium, or low importance in the new system, or they can be labeled with the version of the system that will address the requirements. This practice is particularly important when using object-oriented methodologies, since they deliver a system in an incremental manner. The most obvious purpose of the requirements definition is to provide the information needed by the other deliverables in analysis, which include functional, structural, and behavioral models, and to support activities in design. The most important purpose of the requirements definition, however, is to define the scope of the system. The document describes to the analysis exactly what the system needs to end up doing. When discrepancies arise, the document serves as the place to go for clarification, and this is the most important thing. And now we need to determine some requirements. The determining requirements are an important part because determining requirements for the requirements definition is both a business task and an information technology task. In the early days of computing, there has a presumption that the systems analysis as expert with computer system were in the best position to define how a computer system should operate. Many systems failed because they didn't adequately address the true business needs of the users. Gradually, the presumption changed so that the users, as a business expert, were seen as being the best position to define how a computer system should operate. However, many systems failed to deliver performance benefits because users simply automate an existing inefficient system, and they fail to incorporate new opportunities offered by technology. Therefore, the most effective approach is to have both business people and analysts working together to determine business requirements. Sometimes, however, users don't know exactly what they want, or the major part of the time they don't know that. And analysts need to help them discover their needs. A set of strategies has become popular to help analysts do problem analysis, root cause analysis, duration analysis, activity-based costing, informal benchmarking, outcome analysis, technology analysis, and activity elimination. Analysts can use these tools when they need to guide the user in explaining what is wanted from a system. Although these strategies enable the analyst to help users create a vision for the new system, they are not sufficient for extracting information about the detailed business requirements that are needed to build it. Therefore, analysts use a portfolio of requirements gathering techniques to acquire information from users. The analyst has many techniques from which to choose, for example, interviews, questionnaires, observation, joint application development, and document analysis, etc. And the information gathered using these techniques is critically analyzed and used to craft the requirements definition report. But what is a creating requirements definition? Creating a requirements definition is an iterative and ongoing whereby the analyst collects information with requirements gathering techniques, critically analyze the information to identify appropriate business requirements for the system, and adds the requirements to the requirements definition report. The requirements definition is kept up to date so that the report team and business user can refer to it and get a clear understanding of the new system. To create a requirements definition, the project team first determines the kinds of functional and non-functional requirements that they will collect about the system. These become the main section of the document, and next the analysts use a variety of requirements gathering techniques to collect information, and they list the business requirements that were identified from that information. Finally, the analysts work with the entire project team and the business users to verify, change, and complete the list, and to help prioritize the importance of the requirements that were identified. This process continues throughout analysis, and the requirements definition evolves over time as new requirements are identified and as the project moves into later phases of the unified process. The evolution of the requirements definition must be carefully managed. The project team can keep adding to the requirements definition, or the system will keep growing and growing and growing and growing and never get finished. Instead, the project team carefully identifies requirements and evaluates which one fit within the scope of the system. When a requirement reflects a real business need, but it's not within the scope of the current system or current release, it's either added on a list of future requirements or given a low priority. The management of requirements is one of the hardest parts of managing a project, and the other part of the functions of one project manager. Then the requirements analysis strategies that we need to know are some of that give us a better performance in the requirements gathering. Before the project team can determine what requirements are appropriate for a given system, there needs to be a clear vision of the kind of system that will be created and the level of change that it will bring onto the organization. The basic process of analysis is divided into 3 steps: understanding the as-is system, identifying improvements, and developing requirements for the to-be system. Sometimes the first step is skipped or is performed in a cursory manner. This happens when no current system exists. If the existing system and processes are irrelevant to the future system, or if the project team is using a RAD, it's a rapid application development or agile development methodology in which the as-is system is not emphasized. Newer rapid application development, agile and object-oriented methodologies such as phased development, prototyping, throwaway prototyping, extreme programming, and Scrum focus almost exclusively on improvements and to-be systems requirements, and they spend little time investigating the current as-is system. Requirements analysis strategies help the analyst lead user through the analysis steps so that the vision of the system can be developed. Requirements analysis strategies and requirements gathering techniques go hand in hand. Analysts use requirements gathering techniques to collect information. Requirements analysis strategies drive the kind of information that is gathered and how it is ultimately analyzed. The requirements analysis strategies and requirements gathering happen concurrently and are complementary activities. To move the user from the as-is system to the to-be system, an analyst needs a strong critical thinking skill. Critical thinking is the ability to recognize strengths and weaknesses and recast an idea in an improved form. And critical thinking skills are needed to really understand issues and develop new business processes. These skills are also needed to thoroughly examine the results of requirements gathering, to identify business requirements, and to translate those requirements into a concept for the new system. And we need to know some phases inside the requirements analysis strategies. The first one is the problem analysis. The most straightforward and probably the most commonly used requirements analysis technique is problem analysis. Problem analysis means asking the user and managers to identify problems with the as-is system and to describe how to solve them into the to-be system. Most users have a very good idea of the change they would like to see, and most are quite vocal about suggesting them. Most change tend to solve problems rather than capitalize on opportunities, but the latter is possible as well. Improvements from problem analysis tend to be small and incremental. This type of improvement often is very effective at improving a system efficiency or easy of use. However, it often provides only minor improvements in business value. The new system is better than the old, but it may be hard to identify significant monetary benefits from the new system. The next is the root cause analysis. The ideas produced by problem analysis tend to be solutions to problems. All solutions make assumptions about the nature of the problem, assumptions that may or may not be valid. In our experience, users and most people in general tend to quickly jump to solutions without fully considering the nature of the problem. Sometimes the solutions are appropriate, but many times, or most of the times, they address a symptom of the problem, not the true problem or cause itself. For example, suppose a firm notices that its users report inventory stockouts. The cost of inventory stockouts can be quite significant. In this case, since they happen frequently, customers could find another source for the items that they are purchasing from the firm. Root cause analysis therefore focuses on problems, not in solutions. The analysts start by having the user generate a list of problems with the current system and then prioritize the problems in order of importance, starting with the most important. The user and/or the analyst then generate all the possible root cause for the problems. Each possible root cause is investigated, starting of course with the most likely or easiest to check, and is investigated until the true root cause are identified. If any possible root cause are identified for several problems, those should be investigated first because there is a good chance they are the real root cause influencing the symptom problems. In our example, there are several possible root causes. The firm supplier might not be delivered orders to the firm in the timely manner. Other can be there could be a problem with the firm inventory controls, and another could be the reorder level and quantities could be set wrong, and probably there are many others. But sometimes using a hierarchical chart to represent the causal relationship helps with the analyst. As the example shows, or you can look in the image in the slide, there are many possible root causes that underlie the high-level cause identified. The key point in the root cause analysis is always to change the obvious. If you have something that fails obviously, you need to change, but first you need to identify it. Then another technique is another procedure is the duration analysis. Duration analysis requires a detailed examination of the amount of time it takes to perform each process in the current as-is system. The analyst begins by determining the total amount of time it takes on average to perform a set of business processes for a typical input. They then time each of the individual steps in the business process. The time to complete the basic step is then totaled and compared to the total for the overall process. A significant difference between the two, and in our experience the total time often can be 10 or even 100 times longer than the sum of the parts, indicates that this part of the process is badly in need of a major overhaul. For example, suppose that the analysts are working on a home mortgage system and discover that on average it takes 30 days for the bank to approve a mortgage. They then look at each of the basic steps in the process, for example, data entry, credit check, title search, appraisals, and others, and find that the total amount of time actually spent on each mortgage is about 8 hours. This is a strong indication that the overall process is badly broken because it takes 30 days to perform 1 day's work. These problems probably occur because the process is badly fragmented. Many different people must perform different activities before the process finishes. Processes in which many different people work on small parts of the inputs are prime candidates for process integration or parallelization. Process integration means changing the fundamental process so that fewer people work on the input, which often requires changing the processes and retraining staff to perform a wider range of duties. Process parallelization means changing the process so that all the individual steps are performed at the same time. For example, in the mortgage application case, there is probably no reason that the credit check account can be performed at the same time as the appraisal and probably the title check. And we have then to know what is activity-based costing or this other procedure. Activity-based costing is a similar analysis. It determines the cost of each major process or a step in a business process rather than the time taken. The analysts identify the cost associated with each of the basic functional steps or processes, identify the costliest processes, and focus their improvement efforts on them. Assigning cost is conceptually simple. Analysts simply examine the direct cost of labor and materials for each input. Material costs are usually assigned in a manufacturing process, whereas labor costs are usually calculated based on the amount of time spent on the input and the hourly cost of the staff. However, as you may recall from a managerial accounting course, there are indirect costs such as rent, depreciation, and so on that also can be included in activity costs. Then everything that are directly or indirectly costing in one activity or one input, you need to consider all of that cost. And another procedure, it's the informal benchmarking. Benchmarking refers to studying how other organizations perform a business process in order to learn how your organization can do something better. Benchmarking helps the organization by introducing ideas that employees may never have considered but that have the potential to add value. Informal benchmarking is fairly common for customer-facing business processes, for example, processes that interact with the customer. With informal benchmarking, the managers and analysts think about other organizations or visiting them as customers to watch how the business process is performed. In many cases, the business studied may be a known leader in the industry or simply a related firm. It's important to try to consider the leaders of the industry over other kind of business. Outcome analysis focuses on the fundamental outcomes that provide value to customers. Although these outcomes sound as though they should be obvious, they often are not. For example, consider an insurance company. One of its customers has just had a car accident. What is the fundamental outcome from the customer's perspective? Traditionally, insurance companies have answered this question by assuming the customer wants to receive the insurance payment quickly. To the customer, however, the payment is only a means to the real outcome, a repaired car. Then the important thing here is not the payment, it's obviously the repaired car. The insurance company might benefit by extending its view of the business processes past its traditional boundaries to include not paying for repairs but performing the repairs or contracting with an authorized body shop to do them. With this approach, system analysts encourage the managers and project sponsors to pretend they are customers and do think carefully about what the organization, products and services enable the customers to do and what they could enable the customers to do. And the last one is the technology analysis. Many major change in business since the turn of the century have been enabled by new technologies. Technology analysis starts by having the analysts and managers develop a list of important and interesting technologies. Then the group systematically identifies how every technology could be applied to the business process and identify how the business will benefit. It is important to note that the technology analysis is no way implies adopting technology for technology's sake. Rather, the focus is on using new technologies to meet the goals of the organization. And we have the activity elimination. The analysts and managers work together to identify how the organizations could eliminate each activity in the business process, how the function could operate without it, and what effects are likely to occur. Initially, managers are reluctant to conclude that processes can be eliminated, but this is a force-fit exercise in that they must eliminate each activity. In some cases, the results are silly. Non-lead participants must address every activity in the business processes. And now we need to know about the requirements gathering techniques that are part of these processes. The requirements gathering process is used for building political support for the project and establishing trust and rapport between the project team building the system and the user who ultimately will choose to use or not use the system. Involving someone in the process implies that the project teams view that person as an important resource and value his or her opinions. All the key stakeholders must be included in the requirements process gathering. The requirements gathering process, The stakeholders might include managers, employees, staff members, and even some customers and suppliers. If a key person is not involved, that individual might feel slighted, which can cause problems during implementation. For example, how could they have developed the system without my input? And every input are needed, or we need all the real inputs to construct or to develop a good system. The second challenge of requirements gathering is to choosing the way information is collected. There are many techniques for gathering requirements that vary from asking people questions to watching them work. Each technique has its own strengths and weaknesses. many of which are complementary, so most projects use a combination of techniques. It's the better way. These are the interview, the Young application development, questionnaires, document analysis, observation, concept and maps, user stories, brainstorming, storyboard, prototyping, and use cases. And there are others, but these are the most important or most used. And we start with the interview. The interview is a common technique used for gather data on information. In this technique, interviewer conduct a meeting with interviewer. Interviews questions should be according to the interviewer's level, gather information according to his or her requirements. Questions should be open, and however, interview can provide clear answer of your question. In general, interviews are conducted one-on-one, but sometimes owing to time constraints, several people are interviewed at the same time. There are 3 basic steps to the interview process: are selecting interviews, designing interview question, preparing for the interview, conducting the interview, and post-interview follow-up. The selecting interviewees, we have the first step in the interviewing is to create an interview schedule listing who will be interviewed, when, and for what purpose. And we can consider to make a table like in the example. The schedule can be an informal list that is used to help set up meetings times, or a formal list that is incorporated into the work plan. The people who appear on the interview schedule are selected based on the analyst information needs. The project sponsor, key business users, and other members of the project team can help the analyst determine who in the organization can best provide information or important information about the requirements. These people are listed on the interview schedule in the order in which they should be interviewed. People at different levels of the organization have varying perspective on the system, so it is important to include both managers who manage the process and staff who actually perform the processes to gain both high-level and low-level perspectives on an issue. Also, the kinds of interview subjects can change over time. It is common to begin by interviewing 1 or 2 senior managers to get a strategic view, and then to move to middle-level managers who can provide broad, overarching information about the business process and the expected role of the system being developed. Once the analyst has a good understanding of the big picture, lower-level managers and staff members can fill in the exact details of how the process works. It is quite common for the list of interviews to grow, often by 50 to 75%. As people are interviewed, more information that is needed, and additional people who can provide information will probably be identified. It's something that occurs in a cycle. Designing interview questions, it's the second step for an interview. There are 3 types of interview question: the close-end question that are structured, the open-end question that are unstructured, and the probing question that are semi-structured. Close-end questions are those that require a specific answer. They are similar to multiple choice or arithmetic question on exam. Close-end questions are used when analyst is looking for specific, precise information. In general, precise questions are best. Close-end questions enable analysts to control the interview and obtain the information they need. However, this type of question don't uncover why the answer is the way it is, nor do they uncover information that the interviewer does not think to ask for ahead of time. Open-ended questions are those that leave room for elaboration on the part of the interviewer. There are similar in many ways to easy questions that you may find on an exam. Open-end questions are designed to gather rich information and give the interviewer more control over the information that is revealed during the interview. Sometimes the information that the interviewer chooses to discuss uncovers information that is just as important as the answer. For example, if the interview talks only about the other departments when asked for problems, it may suggest that he or she is reluctant to admit he or her own problems. And we remember that we are looking problems to give a solution and of course a system. Proving questions follow up on what has just been discussed in order to learn more, and they often are used when the interviewer is unclear about the interview's answer. They encourage the interview to expand on or to confirm information from a previous response, and they signal that the interview is listening and is interested in the topic under discussion. Many beginning analysts are reluctant to use proving questions because they are afraid that the interview might be offended at being challenged, or because they believe it shows that they didn't understand what the interview said. When done politely, proving question can be a powerful tool in requirements gathering. Of course, if we mix these three types of question, it's a better way. In general, an interviewer should not ask questions about information that is readily available from other sources. This helps focus the interview on the task and save time, because the interview doesn't need to describe the information in detail. He or she just needs to point it out on the form or report. No type of question is better than another, and combination of questions is usually used during an interview. At the initial stage of an information system development project, the as-is process can be unclear, so the interview process begins with unstructured interviews that seek broad and roughly defined information. In this case, the interviewer has a general sense of the information needed, but the few close-end questions to ask. There are the most challenging interviews to conduct because they require the interviewer to ask open-ended questions and prove the important information on the fly. As the project processes, the analyst comes to understand the business process much better and needs very specific information about how business processes are performed, exactly how a customer's credit card is approved, for example. At this time, the analyst conducts a structured interview in which specified sets of questions are developed before the interviews. There usually are more close-end questions in a structured interview than in the unstructured approach. No matter what kind of interview is being conducted, interview questions must be organized into a logical sequence so that the interview flows well. There are two fundamental approaches to organizing the interview's question: top, down, or bottom up. With the top-down interview, the interviewer starts with broad, general issues and gradually works toward more specific ones. With the bottom-up interview, the interviewers start with very specific questions and moves to broad questions. In practice, analysts mix the two approaches, starting with broad general issues, moving to a specific question, and then returning to general issues. The top-down approach is an appropriate strategy for the most interviews. It enables the interviewee to become accustomed to the topic before he or she needs to provide the specifics. It also enables the interviewer to understand the issues before moving to the details, because the interviewer might not have sufficient information to the start of the interview to ask very specific questions. Perhaps most importantly, the top-down approach enables the interview to raise a set of big-picture issues before becoming enmeshed in details, so the interviewer is less likely to miss important issues. One case in which the bottom-up strategy may be preferred is when the analyst already has gathered a lot of information about issues and just need to fill in some holes with details. Bottom-up interviewing may be appropriate if lower-level staff members feel threatened or unable to answer high-level questions. In any event, all interviews should begin with non-controversial questions and then gradually move into more contentious issues after the interviewer has developed some rapport with the interview. Then we need to prepare for the interview. It is important to prepare for the interview in the same way that you will prepare to give a presentation. The interviewer should have a general interview plan listing the questions to be asked in the appropriate order, should anticipate possible answers and provide follow-up with them, and should identify sex between related topics. The interviewer should confirm the areas in which the interview has knowledge, so as not to ask questions that the interview can answer. Review the topic areas, the question, and the interview plan, and clearly decide which have the greatest priority in case time runs short. In general, structure interviews with close-end questions take more time to prepare than unstructured interviews, but some beginning analysts prefer unstructured interviews, thinking that they can wing it. This is very dangerous and often counterproductive, because any information not gathered in the first interview will require follow-up efforts, and most users don't like to be interviewed repeatedly about the same issues. The interview should be sure to prepare the interviewer as well. When the interview is scheduled, the interviewer should be told the reason for the interview and the areas that will be discussed far enough in advance so that he or she has time to think about the issues and organize his or her thoughts. This is particularly important when an interviewer is an outsider to the organization and for lower-level employees who often are not asked for their opinions and who may be uncertain about why they are being interviewed. Next step in the interview is to conduct the interview. The first goal is to build rapport with the interview so that he or she trusts the interviewer and willing to tell the whole truth, not just give the answer that he or she thinks are wanted. The interviewer should appear to be professional and unbiased, independent seeker of information. The interview should start with the explanation of why the interviewer is there and why he or she has chosen to interview the person. Then the interviewer should move into the planned interview questions. This is the way that we need to conduct an interview. It is critical to carefully record all the information that the interviewer provides. The best approach is to take carefully notes. The interviewer should be afraid to ask the person to slow down or to pause while writing, because this is a clear indication that the interview's information is important. One potentially controversial issue is whether or not to tape record an interview. Recording ensures that the interviewer does not miss important points, but it can be intimidating for the interviewer. Most organizations have policies or generally accept practices about the recording of interviews, so they should be determined before an interview. If the interviewer is worried about missing information and can't type the interview, then he or she can bring along a second person to take detailed notes. As the interview process progresses, it is too important to understand the issues that are discussed. If the interviewer doesn't understand something, he or she should ask for clarification. The interviewer should not be afraid to ask a dumb question, because the only thing worse than appearing dumb is to be dumb by not understanding something. If the interviewer doesn't understand something during the interview, he or she certainly won't understand it afterwards. One good strategy to increase understanding during an interview is to periodically summarize the key points that the interview is communicating. This avoids misunderstandings and also demonstrates that the interviewer is listening. Finally, facts should be separated from opinion. The interview may say, for example, "We process too many card requests." This is an opinion, and it is useful to follow this up with a probing question requesting support for the statement. It is helpful to check the facts, because any difference between the facts and the interview's opinion can point out key areas for improvement. Suppose that the interview complains about a high or increasing number of errors, but the logs show that errors have been decreasing. This suggests that errors are viewed as a very important problem that should be addressed by the new system, even if they are declining. As the interview draws to a close, the interviewer should have time to ask questions or provide information that he or she thinks is important but hasn't part of the interview plan. In most cases, the interviewer has no additional concerns or information, but in some cases this leads to unanticipated but important information. Likewise, it can be useful to ask the interview if there are other people who should be interviewed. The interview should end on time. And as a last step in the interview, the interviewer should briefly explain that will happen. The interviewer shouldn't prematurely promise certain features in the new system or a specific deliverable date, but he or she should reassure the interview that his or her time has well spent and very helpful to the project. And this last point is the very important point to pay attention, because sometimes when we are in the requirements phase, the client or the customer asks about, for example, a delivery date. but it's important to understand that in this point we have no clear idea about what is the period of time that we need for that delivery, and it's important to don't give that maybe in a random, or because I think, or whatever other that we think that it's better to answer this question, and maybe in the future we fail in the delivery date, and the customer feels bad about this question that we prematurely promise or ask or give an answer about this kind of question. We need to understand that in this part we are just asking for some information, because we have other phases in which we are working on it, and we maybe explain that or answer that question in the future. And the last part of an interview is the post-interview follow-up. After the interview is over, the analyst needs to prepare an interview report that describes the information from the interview. The report contains interview notes, information that was collected over the course of the interview, and is summarized in a useful format. In general, the interview report should be written within 48 hours of the interview, because the longer the interviewer waits, the more likely he or she is to forget the information. Then it's because it's better to make it fast. Often the interview report is sent to the interviewee with a request to read it and inform the analyst of clarification or updates. The interviewer needs to be convinced that the interviewer wants his or her corrections to the report. Usually there are few changes, but the need for any significant change suggests that a second interview will be required. Never distribute someone's information without prior approval. It's important to follow this. And we have a little example of how this report it could be in the slide. And we have another technique, information gathering technique, that is joint application development. The joint application development is an information gathering technique that allows the project team, users, and management to work together to identify requirements for the system. The JID is a structured process in which 10 or 20 users meet together under the direction of the facilitator skilled in JID techniques. The facilitator sets the meeting's agenda and guides the discussion, but doesn't join in the discussion as a participant. He or she doesn't provide ideas or opinions on the topics under discussion, so as to remain neutral during the session. The facilitator must be an expert in both growth process technique and system analysis and design techniques. One or two scribes assist the facilitator by recording notes, making copies, and so on. Often the scribes use computers and case tools to record information as the JID session proceedings. The JID group meets for several hours, several days, or several weeks until all the issues have been discussed and the needed information is collected. Most JID sessions take place in a specially prepared meeting room away from the participants' offices so that they aren't interrupted. The meeting room is usually arranged in a U shape so that all participants can easily see each other. At the front of the room are a whiteboard, flip card, and or overhead projector or laptop for use by the facilitator leading the discussion. JID suffers from the traditional problems associated with groups. Sometimes people are reluctant to challenge the opinions of others, sometimes with their boss, and a few people often dominate the discussion and not everyone participates. In a 15-member group, for example, if everyone participates equally, then each person can talk for only 4 minutes each hour and must listen for the remaining 56 minutes. Not a very efficient way for a collection information. But there is a new form of JID called electronic JID or EAJID. Attempts to overcome these problems by using group aware. In the electronic JID meeting room, each participant uses special software on a network computer to send anonymous ideas and opinions to everyone else. In this way, all participants can contribute at the same time without fear of reprisal from people with different opinions. Initial research suggests that electronic JID can reduce the time required to run JID sessions by 50 to 80%. A good JID approach follows a set of 5 steps. These steps start with selecting participants. JID are selected in the same way as are interview participants based on the information they can contribute in order to provide a broad mix of organizational levels and to build political support for the new system. The need for all JID participants to be away from their office at the same time can be a major problem. The office might need to be closed or operate with a skeleton staff until the JID sessions are complete. Ideally, the participants who are released from regular duties to attend the JID session should be the very best people in that business unit. However, without strong management support, JID sessions can fail because those selected to attend the JID session are people who are less likely to be missed. The facilitator should be someone who is an expert of JID or electronic JID techniques, and ideally someone who has experience with the business under discussion. In many cases, the JID facilitator is a consultant, external consultant to the organization because the organization may not have a recurring need for JID or electronic JID expertise. Developing or managing or maintaining this expertise in-house can be expensive. And the next step is design a JID session. The JID session can run from as little as half a day to several weeks, depending upon the size and scope of the project. In most JID sessions tend to last 5 to 10 days, spread over a 3-week period. Most JID sessions tend to last 1 to 4 days in a 1-week period. JID and electronic JID sessions usually go beyond collecting information and move into analysis. For example, the user and the analyst collectively can create analysis deliverables such as the functional models or the requirements definition. And the JID sessions usually are designed and structured using the same principles as interview. Most JID sessions are designed to collect specific information from users, and these techniques developing a set of questions before the meeting. One difference between JID and interviewing is that the JAD sessions are structured. They must be carefully planned, and in general, closing questions are seldom used because they don't spark the open and frank discussion that is typical of JADD. In our experience, or in my experience, it is better to proceed top-down in JAD sessions when gathering information. Typically 30 minutes is allocated to each separate agenda item, and frequently breaks the schedule throughout the day because participants tire easily. The next step is preparing for a JAD session. As with interviewing, it is important to prepare the analyst and participants for a JAD session, because the sessions can go beyond the depth of a typical interview and are usually conducted off-site. Participants may be more concerned about how to prepare. It is important that the participants understand what is expected of them. If the goal of the JAD session, for example, is to develop an understanding of the current system, then participants can bring procedure manuals and documents with them. If the goal is to identify improvements for a system before they come to the JAD session, they can think about how they will improve the system. It depends on the objective of the session itself. During a JAD session, most JAD sessions follow a formal agenda, and most have a formal ground rules that define appropriate behavior. Common ground rules include following the schedule, respecting others' opinion, accepting disagreement, and ensuring that only one person talks at a time. The role of the JAD facilitator can be challenging. Many participants come to the JAD sessions with strong feelings about the system to be discussed. Channeling these feelings so that the session moves forward in a positive direction, and getting participants to recognize and accept opinions and situations different from their own requirements, significant expertise in system analysis and design, JAD, and interpersonal skills. Few system analysts attempt to facilitate JAD sessions without being trained in JAD techniques, and most apprentices with a skilled JAD facilitator before they attempt to lead their first session. The JAD facilitator performs three key functions. First, he or she ensures that the group sticks to the agenda. The only reason to decrease from the agenda is when it becomes clear to the facilitator, the project leader, and the project sponsor that the JAD session was produced some new information that is unexpected and requires the JAD session to move in a new direction. When participants attempt to divert the discussion away from the agenda, the facilitator must be firm but polite in leading the discussion back to the agenda and getting the group back on track. Second, the facilitator must help the group understand the technical terms and jargon that surround the system development process, and help the participants understand the specific analysis techniques used. Participants are experts in the area and they're part of the business, but they are not experts in system analysis. The facilitator must therefore minimize the learning required and teach participants how to effectively provide the right information. Third, the facilitator records the group's input on a public display area, which can be whiteboard, flip chart, or computer display. He or she structures the information that the group provides and helps the group recognize key issues and important solutions. The facilitator must remain neutral at all times and simply help the group through the process. The moment the facilitator offers an opinion of an issue, the group will see him or her not as a neutral party, but rather as someone who could be attempting to sway the group into some predetermining solution. However, this doesn't mean that the facilitator shouldn't try to help the group resolve issues. For example, if two items appear to be the same to the facilitator should not say, "I think these be similar." Instead, the facilitator should ask, "Are these similar?" If the group decides that are, then the facilitator can combine them and move on. However, if the group decides that are not similar, the facilitator should accept the decision and move on. The group is always right, and the facilitator has no opinion. That is important in this kind of technique. And the last one step is the past JAD follow-up. As the interview, a JAD's post-session report is prepared and circulated among session attendants. The post-session report is essentially the same as the interview report. Because the JAD sessions are longer and provide more information, it usually takes a week or two after the JAD session before the report is complete. And we can use the same template that the interview. The next technique is the questionnaires. A questionnaire is a set of written questions used to obtain information from individuals. Questionnaires are often used when there is a large number of people from whom information and opinions are needed. In questionnaires are a common techniques with systems intended for use outside the organization or for systems with business users spread across many geographical locations. Most people automatically think of paper when they think of questionnaires, but today more questionnaires are being distributed in electronic form, either via email or on the web. Electronic distribution can save a significant amount of money as compared to distributing paper questionnaires. A good process to use when using questionnaires follows 4 steps. The first step is to select participants. As with the interviews and JAD sessions, the first step is to identify the individuals to whom the questionnaire will be sent. However, it's not usual to select every person who could provide useful information. The standard approach is to select a sample or subset of people who are representative of an entire group. Sampling guidelines are discussed in most statistics books, and most business schools include courses that cover this topic. The important point in selecting a sample, however, is to realize that not everyone who receives a questionnaire will actually complete it. On average, only 30 or 50% of paper and email questionnaires are returned. Response rates for web-based questionnaires tend to be significantly lower, only 5 to 30%, more or less. And the next step is designing a questionnaire. Because the information of a questionnaire can be implemented, clarified for a confused respondent, developing good questions is critical for questionnaires. Questions on questionnaires must be very clearly written and leave little room for misunderstanding. So, questions tend to be most commonly for the users. Questions most clearly enable the analyst to separate facts from opinions. opinions question often asks respondents to extent to which they agree or disagree, and whereas factual questions seek more precise values. And we have some examples of questionnaire design in the slide, in the image. Perhaps the most obvious issue is to have a clear understanding of how the information collected from the questionnaire will be analyzed and used. This issue must be addressed before the questionnaire is distributed, because it's too late afterward. Questions should be relatively consistent in style, so that the respondent doesn't have to read instructions for each question before answering it. It is generally good practice to group related questions together to make them simpler to answer. Some experts suggest that questionnaires should start with questions important to respondents, so that the questionnaire immediately grabs their interest and induces them to answer it. Perhaps the most important step is to have several colleagues review the questionnaires and then pretest it with a few people drawn from the groups to whom it will be sent. It is surprising how often seemingly simple questions can be misunderstood. And the next step is administering the questionnaire. The key issue in administering the questionnaire is getting participants to complete the questionnaire and send it back. Dozens of marketing research books have been written about ways to improve response rates. Commonly used techniques include clearly explaining why the questionnaire is being conducted and why the respondent has been selected, and stating a date by which the questionnaire is to be returned, offering an inducement to complete the questionnaire, and offering to supply a summary of the questionnaire responses. System analysts have additional techniques to improve response rates inside the organization, such as personally handing out the questionnaire and personally conducting those who have not returned them after a week or two, as well as requesting the respondent supervisor to administer the questionnaires in a group meeting. And the last step is questionnaire follow-up. It is helpful to process the returned questionnaires and develop a questionnaire report soon after the questionnaires deadline. This ensures that the analysis process proceeds in a timely fashion, and that the respondents who request copies of the results receive them promptly. The next technique is document analysis. Project teams often use document analysis to understand the ASI system under ideal circumstances. The project team that developed the existing system will have produced documentation that has then updated by all subsequent projects. In this case, the project team can start by reviewing the documentation and examining the system itself. Unfortunately, many systems are not well documented because project teams fail to document their projects along the way, and when the projects are over, there is no time to go back and document. Therefore, there might not be much technical documentation about the current system available, or it might not contain updated information about recent system change. However, many helpful documents do exist in an organization, for example, paper reports, memorandums, policy manuals, user training manuals, organization charts, forms, and of course the user interface with the existing system. But these documents tell only part of the story. They represent the formal system that the organization uses. Quite often the real or informal system differs from the formal one, and these differences, particularly large ones, give a strong indication of what needs to be changed. For example, forms or reports that are never used should probably be eliminated. Likewise, boxes or questions on forms that are never filled in should be retrowed. And we have an example of how a document can be interpreted of this document analysis technique in the picture in the slide. The most powerful indication that the system needs to be changed is when users create their own forms or add additional information to existing ones. Such change clearly demonstrates the need for improvements to existing system. Thus, it is useful to review both blank and complete form to identify these deviations. Likewise, when users access multiple reports to satisfy their information needs, it is a clear sign that new information or new information formats are needed. And the next technique is the observation. Observation, the act of watching processes being performed, it's a powerful tool for gathering information about a system because it enables the analyst to see the reality of a situation rather than listening to others describing it in interviews or JAD sessions. Several research studies have shown that many managers really don't remember how they work and how they allocate their time. Observation is a good way to check the validity of information gathered from indirect sources such as interviews and questionnaires. In many ways, the analyst becomes an anthropologist of he or she walks through the organization and observes the business system as it functions. The goal is to keep a low profile, not interrupt those working, and not influence those being observed. It is important to understand that what analysts observe may not be the normal day-to-day routine because people tend to be extremely careful in their behavior when they are being watched. Even though normal practice may be to break formal organizational rules, the observer is unlikely to see this. Thus, what you see might not be what you get. What you see might not be what you get. Observation is often used to supplement interview information. The location of the person's office and its furnishing give clues to the person's power and influence in the organization and can be used to support or refute information given in an interview. In most cases, observation supports the information that users provide in interviews. When it doesn't, it is an important signal that extra care must be taken in analyzing the business system. And we have another technique, the concept maps. Concept maps represents meaningful relationship between concepts that are useful for focusing individuals on the small number of key ideas on which they should concentrate. A concept map is essentially a node and arc representation where the nodes represent the individual requirements and the arc represent the relationships among the requirements. Each arc is labeled with relationship name. Concept maps also have been recommended as a possible technique to support modeling requirements for object-oriented system development and knowledge management system. Concept Concept mapping is an educational psychology technique that has been used in schools, corporations, and healthcare agencies to facilitate learning, understanding, and knowledge creation. The advantage of the concept mapping approach to representing requirements over the typical textual approach is that a concept map is not limited to a hierarchical representation. Concept maps allow the representations among the functional and non-functional requirements to be explicitly represented. By using a concept map to represent the requirements instead of the contextual textual approach, the relationship between the functional and non-functional requirements can be made explicit. For example, the two security requirements only doctors set availability and only managers can produce a schedule be explicitly linked to the record doctor availability and produce schedule functional requirements respectively. This is very difficult to represent in a text-only version of the requirements definition. Also, by having the user and analyst focus on the graphical layout of the map, additional requirements can be discovered. One obvious issue with the approach is that if the number of requirements becomes many and the relationship between them become complex, then the number of nodes and arcs will become so intertwined that the advantage of being able to explicitly see the relationships will be lost. However, by combining both text and concept map representation, it is possible to leverage the strength of both textual and graphical representation to more completely represent the requirements. We have an example of a concept map in the slide. The next technique is user stories. User stories, along with their associated story card and task list, are associated with the agile development approach. User stories have been shown to be very useful in gathering requirements in a non-threatening manner that respects the user's points of view. They are typically captured using a story card and are recorded on a task list. Both story cards and task list are considered to be a lightweight approach to documenting and gathering requirements. Stories capture both functional and non-functional requirements. For example, with regard to the doctor office appointment example, a functional requirement-based story should be, as a secretary, I want to be able to schedule appointments to our patients so that can be meet our patients' needs. While an operational non-functional requirement-based story should be, as a secretary, I want to be able to print the daily schedule using wireless technology so that all printing can be performed using a shared printer without having to deal with printer cables connecting all of the computers of the printer. Once the story is written down, it is discussed to determine the amount of effort it will take to implement it. During the discussion, a task list is created for the story. If the story is deemed to be too large, the story is split up into multiple stories, each being recorded on its own story card, and the tasks are allocated across the new stories. In many shops, once a set of tasks has been identified with the story and its tasks are taped on a wall together so that all members of the development team can see the requirements. And The story can be prioritized by importance by placing a rating on the card. The story can also be evaluated for the level of the risk associated with it. The importance level and amount of risk associated with a story can be used to help choose which requirements to implement first. The advantage of using story cards and task lists to document requirements is that they are very low tech, high touch, easy updatable, and very portable. Then the next technique is the brainstorming. Brainstorming technique is group discussion in which members share their ideas and find out the solution of specific problems. Brainstorming generates or gathers new ideas rather than its quality. This technique is more popular because of its group activity. All the members share an idea. It is more productive for the reason than groups. When members generate idea, it is more valuable as of group product, and members enjoy the group activity. There is method for conducting brainstorming tasks. There are subject and design, procedure, result, and discussion. It is not compulsory to manage brainstorming session to resolve major issues. The purpose of this technique is introducing mission statement for a specific problem. Advantage of this technique is encouraging open mind and free ideas or innovation on particular predefined problem. Next is the storyboard technique. In this technique, user, customer, and developers draw picture of what they want to develop software. Draw picture of all requirements like toolbar, main window, dialogs box, etc. After draw full picture of all requirements, all members agreed upon on it. It is just like paper prototyping. Storyboarding is very common technique for designing about which one to get information for their project. Storyboarding is much realistic for understanding about software structure for unknown person who don't know about technical terms. There are some attributes or elements of a storyboard which explain basic points of drawing storyboard. These are level of detail that describe existence of actor and objects. It depends upon the designer who or how to draw a scene or describe only detail of interface. The inclusion of text in storyboard. Text could be included in designing with each section. It may be a possible designer will not use text. Inclusion of people and emotions during designing. End user should be in mind. Design should be according to end users that affects the user or stakeholders. We have the other element in the storyboard with number of frames that should be in mind. Mostly 1 to 20 frames are included in each story. Each storyboard contains different number of frames according to its requirement. Several features are contained in storyboards. And the last one is portrayal of time. Time pacing is included in storyboard or use transitions. And we have another technique that is prototyping. Prototyping is more significant technique for gathering technique. Through prototyping, detailed requirements can be gathered in preliminary requirement is already collected. If preliminary requirement is already collected, prototyping is much effective for gathering relevant information from users. Users provide relevant information and also provide feedback. This technique is useful when users or stakeholders not aware about technical terms. In this way, They deliver right information and react on the requirement which is developed by designer or developer. Sometimes this technique is expensive in tenure of cost and time. Prototype can be flat diagrams. It helps us to prevent from misperception. The next technique is the use cases. Use cases analysis is a document that defines relationship between actor and system. Arrangement of action. A user uses a system to complete a procedure. Define how system will behave in particular situation. Use case can be used to represent business functionality. An actor is used as interaction with system, how to discuss with system or its environment. Use case will be successful when its goal is satisfied. Use case description also include in use case analysis. Use case steps are written in easy and understandable format of use case diagram. System is preserved such as black box, in which actor presents as home what will be interact as system and purpose or goal for interaction with the system without knowing about internal system. And there is an example of format of use case description in the picture in the slide. Actors who will interact with system, goal of use case description, precondition, and if use case will not be successful, then failure condition. All these points are mentioned in the use case description. Diagram of use case can present with an actor, use case, and system boundary through which actor interacts with use case. And we have an issues in requirements gathering. When talk about the requirements gathering or requirements elicitation, then there may be many issues to gather data from user or stakeholders. Here we'll be describing some issues and solutions of these issues. The issues are scope, communication and understanding, quality of requirements, stakeholders, and practice. And the scope, there are a big issue of requirements. Elicitation is a scope. Sometimes user or stakeholders are not familiar or know the scope of project. They can specify the goal of their project. When a scope issue occurs, then it creates issue to gather information from user. A scope should be limited and clearly defined. However, requirements can be gathered correctly according to user needs or according to nature of projects. And communication and understanding. In communication and understanding issue mostly faced end users. During communication with the stakeholder, some issues may be language issues. Stakeholder may be possible they don't know the language, or it may be possible they are not familiar with the condition, with your condition and terms. And they have many other kinds or issues in this in this issue, in this requirements gathering activity. Others are stakeholder participant and selection, or the stakeholder interaction, the communication activities and techniques as others. In the quality of requirements, during gather information, some users not provide right information, they are not serious. Sometimes their environment at that time is not according to their needs, so they are not able to provide right information. And this could be a problem. Solution is that carefully gets information according to their needs and put limited questions and get to the point answer. In this way, quality of requirement can be improved. The stakeholder is one of the main issues during requirements gathering. They don't satisfy on one point because they really not know about technical terms. For example, they have no idea about software working and system, how it works, and the issue rose due to unawareness of stakeholders. They don't cooperate all the time with project team members. On the other hand, they are not able to finalize the solution of decision of any problems, and these are some conflicts that should be removed. And the practice, generally practice is good factor in requirements gathering. Sometimes non-expert analysis are available for requirement gathering, or there may be some gap between requirement theory and practice, and some analysts repeat mistake again and again, so hire experienced analysts for this purpose. And we are in the part of selecting the appropriate technique. Each of the requirements gathering techniques discussed in all this video has a strengths and weakness. No one technique is always better than other, and in practice most projects use a combination of techniques. Thus it is important to understand the strengths and weakness of each technique and when to use each one. One issue not discussed is that of the analyst experience. In general, document analysis and observation require the least amount of training, whereas JID sessions are the most challenging. In any project, main first phase is requirement elicitation or requirement gathering. Requirement gathering. Right and correct information from stakeholders are actually significant for successful and without any defect project. So this information of this video is about different techniques of requirements gathering. The next part we are discussing about the how to implement and what we need to do when we are obtaining the requirements and how to convert it to a system requirements. And that's it, guys. Thank you for listening, and I expect you see you guys in the next video. And remember, proudly UTI.